Perfect. All right, 5-2, equilateral and isosceles triangles. No proofs yet, guys, but soon. Topic 5-2, equilateral and isosceles triangles. A lot of this stuff we've actually already talked about. It's now just applying it in some different kinds of problems. So who can refresh my memory about what an isosceles triangle even is? What is an isosceles triangle? Yeah, exactly, Ethan. It's going to have two equal or congruent sides. So because of those congruent sides, we end up having a few different properties that happen and some parts we need to be able to identify here. So this is a picture of an isosceles triangle. An isosceles triangle has what are called legs. That'll happen with isosceles triangles and right triangles. The legs of an isosceles triangle are the two congruent sides. Okay, so the legs are the two congruent sides, and you can see those labeled in your picture. The vertex angle is the angle that is formed by the legs. It's that angle that's going to be, it's the not congruent one. Your two legs intersect and form the vertex angle. The base is simply the third side of the triangle. It's the one that's not congruent. Okay, it's the extra one, kind of. But the base is important because it forms what are called our base angles, and those are the two, what vocab word did I put there? They are the two adjacent angles to the base. In other words, the base angles are the angles on either side of the base. Now, we mentioned this last time. There's actually something important about those angles. If you have an isosceles triangle, does anyone remember what happens with those angles? Yeah, they end up being equal or congruent. That's why they're important and why we have them, and that is what the isosceles triangle theorem actually tells us. So in our isosceles triangle theorem, it says if two sides of a triangle are congruent, in other words, it's isosceles, then the angles opposite them are congruent. So if you have an isosceles triangle, like in this picture, segment AB is congruent to segment AC, then what happens is the angles across from them end up being congruent. So across from AB is angle C. Across from AC is angle B. And what ends up happening here is that angle B ends up being congruent to angle C. Now, and something else I'd like you guys to keep in mind, notice how B and C are on the bottom here. Do you think they have to be on the bottom? In every single picture, are they always going to be on the bottom? No. What if you took your triangle and you flipped it upside down? Then wouldn't they be on the top? Or if you took your triangle and you flipped it over to the right, or flipped it over to the left? Okay, so a lot of people get preoccupied with that the congruent ones or the base angles have to be on the bottom. People think base, bottom. Not necessarily, because the picture can be drawn in a lot of different ways. Well, if it works this way, it's also going to work the other way. If you're going to have congruent sides, you're going to have congruent angles. But if you have congruent angles, you're also going to have congruent sides. So that's what the converse of the isosceles theorem is. Remember, converse means reverse. It says if two angles of a triangle are congruent, so this time you have your two congruent angles, angles B and C, then the sides opposite them are congruent. So this time it's kind of flipped around. If the angles are congruent, then the sides are congruent. So opposite angle B is side AC, And opposite angle C is side AB. So these sides would have to be congruent. Segment AB would have to be congruent to segment AC. All right, questions about that yet? Pretty straightforward so far, yes? Hopefully. Okay. Then we have the equilateral triangle theorem and its converse. We actually already talked about this too. As I said, it's stuff we've talked about it. We're just like actually applying it now. Remember from last class, before we even go into what it means, what is equilateral? What did that mean? Who remembers? Equilateral triangle. Yeah, equilateral specifically means all the sides are congruent. Equiangular specifically means all the angles are congruent. That's okay, but don't they always go together? If a triangle's equilateral, it's equiangular, and vice versa. That's what this theorem basically says. If a triangle is equilateral, then it is equiangular. And if a triangle is equiangular, then it is equilateral. So this diagram here, this is an example of an equilateral equiangular triangle. All the angles are congruent and all the sides are congruent. Who remembers what the angle measures have to be in an equiangular equilateral triangle? They all have to be 60. Why do they all have to be 60, Caden? Yeah, exactly. All the angles have to add up to be 180. You take 180, you split it into 3 equal pieces. That's 60 for each one. Okay. And then really the rest of this is just trying out some examples. And then you'll have the rest of the time to work. So let's try a few of these out. Complete the following statements. In number 1, we have triangle ABC. And it says if segment AB is congruent to CB, then angle A equals what? Don't guess on these. Please mark up your pictures, okay? Because sometimes they can look deceiving. Don't ever base it off of what your picture looks like. Base it off of the information you're given. So if AB is congruent to CB, I would mark that. Because then that kind of tells you that isn't your triangle like oriented where the base is on the bottom? So if segment AB is congruent to segment CB, angle A is going to have to be congruent to what other angle? Yeah, angle C. That is your isosceles triangle theorem. If the sides are congruent, then the angles opposite them are congruent. Okay. Now look at 2. This one though, well, first of all, hopefully the picture kind of gives it away to you. Doesn't the picture look a little like lopsided? Yeah. It might not always look like that though. Okay, you got to go based on the information. You might even be given one picture and then like in part A given one set of information, in part B given a different set, right? And you got to be able to apply the information in different ways. So in this one, it's telling you angle C is congruent to B. So this one, they kind of took your picture and they twisted it around. So it's saying if that's the case, then segment AB is going to be congruent to what other side? Which one? AC, exactly. Yeah, it's going to have to be congruent to segment AC. And the reason that happens is look at what it's across from, right? Is an angle side AB across from angle C? And then if it helps you draw the arrow, right? I mean, no one else can see you drawing the arrow. From angle B, if you draw an arrow to the opposite side, you're going to hit AC. Okay. Questions about that? All right. On the back, we're going to kind of skip around and do certain things together, and then you're going to do certain things on your own. So, for example, we are going to, which one? I think we're going to look at 2 together first, and then I'm going to have you guys try 1 and well, these ones are a little different. We're going to do 2, and then I'm going to have you guys, I think, try both 1 and 3. 3 is a little trickier, but I think you guys can come up with it. So take a look at 2. What kind of triangle is this in number 2? No, not scalene. Not necessarily right, but it is isosceles. It is definitely isosceles. We got 2 congruent sides. But is it giving us any side measurements here? No, it's giving us angles, right? It wants us to find this angle right here with the x. It gives us that one angle is 41, but that's it. That's all it's giving us. So you got to think, if that angle is 41 and it's isosceles, what else do I know? Any ideas? Trey? Exactly. If this angle is 41, then this angle is going to be 41 as well, because that's across from my congruent sides, right? Good. And now, how do you think we could go about finding x? Trey? Very good. Yep, you know all 3 angles are going to have to add to be 180. And how you set this up is up to you. I'm going to say that x equals 180 minus 41 plus 41. If you want to do that in 2 separate steps, you are 100% welcome to. So that's going to give me 180 minus 82. And Trey, you said that was 98? Yeah, that sounds right. And at the end, you could always add them up, double check, make sure they equal 180 if you get like a number you're unsure of. Good, so think about that, and I want you guys to try out 1 and 3. 1 should be like, there's no work to it. Just write down what the angle is. Okay, 3 you might have to think about a little bit, but I want to see what you guys come up with. Number 1, what's number 1 have to be? Trey? Oh yeah, if you needed to find that one, absolutely. You have your 2 congruent sides here. So these would be your 2 congruent angles. So x would just be 70. And then that's good. Yeah, if you needed to find the other one, add those up and subtract, and that would be 40. Good. What about number 3? Andrew, what do you think? Why 2x? I don't see a 2x. I just see a 1x. Yeah, good. There's more than one good way to set this up. If you're an equation person, you like to have an equation to write out. If this angle here is x, won't this angle have to be x as well? They're going to have to be congruent. So that's definitely a way to do it. X plus x, or go ahead and write 2x, plus 76 equals 180. So 2x equals 104, and divide that to get 52. Did you get 50? I got 52. You did? Well, so you can't assume that the bottom ones are 76. Because those ones, so 76 is the vertex angle. So it's these bottom 2 that are the congruent ones. Well, you might have, you got 52. Maybe what you, because I don't think that would work out in that same way, but I'm trying to think of what maybe you did. 80 minus 28, 76 plus 28. You did a lot of things. I don't know. It ended up working out, I guess. But did anyone do this one alternatively? When I was walking around, I saw a lot of people like just had an answer, which is fine. Tyler? Yeah, good, which is also a really good way to do it. So if you know that, okay, I know that this entire triangle has to equal 180 degrees, and I already have 76 of that, you could subtract that out. You would realize you had 104 degrees, right? But that, if those two angles are congruent, doesn't that have to be split evenly? So that's where that divide by 2 part comes in. So 104 divided by 2 would still equal 52. Either strategy is good. I don't care either way. Do what makes the most sense to you. Now these ones, 4 and 5, are similar, but it's giving you an expression for the angle. So if you want, you can always like redraw it in there. That's what I sometimes do. So here's your isosceles triangle for number 4. This angle is 70, and then angle 2, it's telling you that is actually 8x minus 10. So this angle here is 8x minus 10. It's isosceles, and which two angles are going to be the congruent ones in this scenario? Which two angles are going to be the congruent ones? Yeah, 70 and angle 2, the one that's 8x minus 10, right? You actually do have to do work because, yeah, well, because with this one, if it instead of a 2, if it was an x and you were just solving for x there, then totally. But it's giving you an expression for this one, so it's telling you, hey, this angle is 8x minus 10, so you're gonna have to set that equal to 70. Does that make sense? Okay. So yeah, we gotta set that equal to 70. So 8x minus 10 equals 70. And that's a common mistake with these. I'm going to add my 10 over. 8x equals 80. And divide that out to get 10. Mm-hmm. Yeah, and that's a good strategy. I am going to ask you, so this angle was 65. This vertex angle here was 8x minus 6. What did you use for your third angle? Yeah, that is correct. So can you tell me exactly how you wrote your equation, Gannon? Yeah, that sounds good. That is a great way to do it. Yeah, so these two angles, these are your congruent sides. So these are your congruent base angles. So I would add them all up, set it equal to 180. That would give you 8x. And then what's that? 130 minus 6, 124 equals 180. 8x equals 56. And we should have gotten 7. That's what I would probably do. Another good strategy is you could always add these up and subtract from 180 to get 50, and then set 8x minus 6 equal to 50. Either way would totally be fine. Okay? Make sure you keep that out so you can check these. I know you got them done, but do you have your packet out still? Okay. Okay. All right, number 6. What kind of triangle is this? Well, so right now the angles are, yeah, right now technically the angles are marked as congruent. So technically it's equiangular, but if it's equiangular, what else is it? Equilateral. So all the sides are also congruent. And if all the sides are congruent, what would be a really quick and easy way for me to set this up? Yeah, they're equal, right? They're equal, so set them equal. X plus 5 equals 11, and x equals 6. We did something very similar last class. So then on that note, what's happening with number 7? We also talked about this last class, but this is very commonly missed. I know you're done, Caden, but can you stay off your phone until we're done? It's okay. It just bothers me. You're very popular. So, what do you think we could do here? It is equiangular again, so it's also equilateral, but I'm confused because there's 3 sides labeled and I just don't know what to pick and do. Anna?
Set to 2x minus 15 equals 21. Figure that out, and
Then you're actually done. Yeah. Anna, what were you going to say? So for that, you're thinking like if they were the angles. The sides are all congruent, so you don't necessarily have to add anything together. For these, they're all the same, so just pick any 2 and set them equal to each other. This is one, I talked about this last time, where the really common mistake to make is you add all 3 together and you set it equal to 180. But does not only work with angles. These aren't angles, these are sides. Don't set sides equal to 180. Pick any 2 that are congruent and set them equal to each other. I don't care which 2 you pick. Pick whichever 2 you like. I'm going to go with the 2 that Elle suggested, but I truly don't care because you should get the same answer no matter what. So 2x minus 15 equals 21. 2x equals 36, and x equals 18, or at least hopefully you get the same thing, because I'm not going to lie, I made this problem up and it was kind of hard to figure out how to make it up. So should work. I tested it, but you never know. So that should be 18. Yeah, exactly. I think that's why I made one of them a whole number, because it was easier for me to make sure it worked when I wrote it. But yeah, you could have also just used that base and then it's just subtracted. Same thing. Good. Now, good. I think these are the last 2, right? Yeah. Last 2. A little trickier. There's a couple trickier ones on your homework. We'll find out. You can't assume it. You can't assume it. If maybe there's some other information that you can find out that helps you with it, but we can't assume. Now with this one, these are different kinds of angles kind of combined to make one figure. In number 8, triangle KNL is an equilateral equiangular, and triangle NLM is isosceles, because see the 2 congruent base angles down here? So when I do a problem like this, I like to start kind of labeling what I know is congruent to each other. In this top equilateral equiangular triangle, aren't all the sides going to have to be congruent? Yeah, okay, so I know all my sides are going to have to be congruent. So what's y going to have to equal? 4. That's probably where I would start. That's pretty easy to figure out. So y equals 4. All these sides are going to have to equal 4. How could that maybe help me solve for x? It will be. Andrew, can you tell me how I would figure that out though? Exactly. This triangle down here is isosceles. My 2 base angles are congruent. So that means side LN is congruent to side LM. And aren't all these 4? If it helps you to do it, label all of them as 4, right? That one's 4, that one's 4. And if they're all 4, can't we just do x plus 1 equals 4? So that's how they got 3. And it could be a right angle, Caden, but it doesn't really matter on that one. It would have to be, yeah. This one is definitely 60. We just don't, this one is 60 for sure. We don't know for certain that that one's 30 though. It could be like 32, you know? All right, so then last one, number 9, we got an equilateral equiangular triangle here. This one kind of on the right with the little blue X. And then this little triangle, it's kind of attached on its side. See how we have the two congruent sides? So that one's isosceles. I think you could figure out x right away without actually having to do any additional work. Any ideas or suggestions, Andrew? Why 60? Yeah, it's equilateral, equiangular. So doesn't every angle in there have to be 60? All of them, right? Each one is 60. So x equals 60. Well, that's great and all, but I still need to find y. And y is up here. It's actually that vertex angle of my isosceles triangle. I don't know any of the measurements in that little isosceles triangle, but could I use some of the information we just found out to kind of like work my way up to that part of the picture? Anna, you look like you have an idea. Why would it be 30? Yeah. Yeah, exactly. There was a right angle box here. I kind of drew over it, but there's a right angle box here. And if this angle's 60, if you do 90 minus 60, won't this angle have to be 30? Okay, so that angle's 30. Now think kind of about the first few we did. How could that help me find y? Right, exactly. This is isosceles. Here are your two congruent sides. So if this lower angle down here is 30, won't this top angle also have to be 30? Because remember, your two base angles are congruent. So that one's 30. And then this is like you have this little isosceles triangle where this is y, this is 30, and that's 30. So then don't all three of your angles have to add to be 180? So I would add those up and subtract. So to find y, and you can do this in a few different ways if you want. I like to do this all at once. 180 minus what we have so far, which is 30 plus 30. 30 plus 30 is 60, and 180 minus 60 is 120. Good. Questions, concerns? I think your homework for tonight's just one page, isn't it? Like 10 problems or something? I must have been feeling kind that day.